From the beginning of aviation, in-flight fire or smoke has been a serious event. It demands immediate action by the flight and cabin crews. Although every effort has been made by the aircraft manufacturers to reduce the risk of in-flight fires, fires can still occur for different reasons. In May 11, 1996, an aircraft crashed approximately 10 minutes after takeoff from Miami International Airport. Improperly packed oxygen generators ignited, leading to a fire which burned through control cables and filled the cabin with smoke. There was no warning because the plane was not equipped with fire and smoke detectors, nor was it required to be equipped for its Class D cargo compartment. The flight attendants yelled to the cockpit that the cabin was on fire about 6 minutes after takeoff. Although the flight crew took appropriate actions to cope with the fire, the airplane impacted the ground in large right roll angle and steep nose-down attitude. This occurrence contained some important aspects involved in in-flight fires, and these circumstances will be discussed in this video. The importance of taking immediate and aggressive actions against signs of fires, of known or unknown origin, guidance on how to recognize the sources, and actions to cope with fire or smoke events in flight will also be dealt with. Past experience tells us the typical in-flight fires that have been characterized. They include malfunction of the electric equipment and wiring. Although electrical system design seeks to isolate electric systems to protect current-carrying lines, in most cases an electrical arc acts as the initiating event, igniting other surrounding materials. Generally, this kind of fire, hidden or not, will affect high-current lines, but light wiring spread all through the airframe is a perfect igniter too. You may expect electric fire from avionic equipment, galley ovens and oven exhaust, fluorescent light ballasts, speakers, water heaters, and flushing motors. Faulty circuit breakers that do not trip may affect unit or associated wiring to overheat and ignite. Movie projectors, cabin control equipment, and electric motors are possible causes of attic fire. Bleed air contamination might be another source of hidden fires. Failure of the supply lines may result in air leakage that can cause high temperature in the surrounding area and damage equipment, wiring, airframe structure, and insulation material. Electric motors in the air conditioning system, such as recirculation fans, are subject to overheating and subsequent inducing cabin contamination. As a matter of fact, cabin air can also be contaminated by smoke, noxious fumes, or burning odor produced by a malfunctioning engine or APU. Cases of fire igniting in toilets and cargo compartments have also occurred in the past. Inside the toilet, remainings of cigarettes have been found as villains. There was an extensive history of fires originating in aircraft cargo compartments where loose baggage and cargo are carried. Even cases of overhead bin fires have occurred, such as when a passenger carried gasoline in his hand luggage, which caused a total airplane loss. (1973) July 11th. During the en route flight from Rio de Janeiro to Paris, a liner was forced to and made a successful landing short of the runway at Orly, France airport only 5 minutes after reporting a fire in the rear of the cabin. The fire produced a thick black smoke, which quickly filled the cabin and cockpit. The smoke was so thick in the cockpit that the pilot had to look out the open side windows to make the crash landing. Despite the pilot's successful effort to land the plane, 124 of the 135 persons on board died from the effects of toxic gases produced by the fire. Most of the airplane's fuselage was consumed by a post-impact fire. The accident report found the probable cause to be a fire that originated in the wash basin unit of the aft right toilet. There are some classical signs of fire. The odor is one of the first. Never ignore it. Rely on your nose or on a passenger's nose. You must identify its source as soon as possible. Trace the smell to its strongest location and pinpoint the source, and treat a smoke occurrence as a fire, at least until you see what it is all about. Eye irritation, sore throats, or headaches may indicate that gas fumes are present, but may have not reached a level where they are visible. Smoke is a sure sign of problem, no matter where it is coming from, and you must take immediate action to determine the source. Hot spots on the floor, sidewall, ceiling, or any other panel must be investigated. You must suspect that a failure or uncommanded operation of any aircraft component may indicate a fire is developing. Noises such as popping, snapping, or cracking, which may indicate electrical arcing, possibly igniting what is around. Circuit breaker tripping is another sign of electrical load abnormality. A circuit breaker will open when a predetermined current is detected and will cut off power to the associated system. Resetting a tripped circuit breaker in flight is not recommended. Actually, it is acceptable to reset it just once after a cooling period if the crew judges the associated system is relevant for flight safety. Direct, timely, and aggressive crew response to smoke and fumes of known or unknown origin is the key to minimizing risks and operational consequences. Studies have shown that the crew may have from 15 to 20 minutes to land the aircraft if a fire signal is left unattended. On the other hand, fire can reach uncontrollable levels in a question of minutes. Experience indicates that the crew should plan for an immediate descent and land at the nearest suitable airport after the first indication of fire. One could evaluate whether to continue the flight, considering the confidence in identifying the smoke source, the success in extinguishing the fire, systems functionality, passenger distress, and many others. Considerations like the structural integrity and environment survivability were predominant for defining the specific procedure as they are stated in a QRH. The crew should establish cabin communication and don protective equipment before initiating any procedure associated with smoke or fume elimination in accordance with approved procedures. Pilots should notify the flight attendants to prepare the cabin occupants for an emergency landing and evacuation, and, if appropriate, while assisting in fighting the fire. Do not open the cockpit door unless it is necessary. It will prevent contaminating the cockpit. When a flight crew determines the smoke is coming from the air conditioning system, the procedure stated in the QRH requires the crew to determine which is the bleed pack side responsible for introducing contaminated air into the cabin. If smoke is suspected to be supplied by the engine oil, check abnormal engine parameters to correlate it with the odor. Once the source is isolated, the remaining one will continue to supply fresh air for the passengers and crew. When the smoke is confirmed as of electrical origin, depowering buses or equipment sequentially and leaving that equipment off will eliminate the source of smoke. More specifically, if flight crew identifies a windshield overheating and inhales burning odor from it, Do not waste time and shut windshield heating off.